everybody. Ooh, that's wobbly. There we go. Well, the purpose of this video is to get you guys some solutions to the Chuck-a-Luck extension quiz, if you chose to do it. We're talking about the idea of statistically fair, which is making a game average zero payouts. Average, well, I guess zero payouts, but averaging a dollar value of zero for a pay. If you remember from class, Chuck-a-Luck had certain payouts. If you don't remember, you can go back and watch the videos and then come back and watch this. But you played this game involving dice, and you won, or lost in this case, varying amounts of money depending on what you bet on and how the dice fell. And what I'm having you do here is I want you to adjust the payout for the roll of 3 to make the game fair. Right now, this game has a negative expectation. We calculated it in class. It's negative like 50 cents or 48 cents or something like that. I want to make this... you guys seem to like X, but I'm using X up there. Can I call it Y? I'll call it P for payout. There we go. Call it big P for payout. What would that have to be to make the average payout 0? In order to make that 0, what would the big payout be? And we'll see why this is important momentarily. It actually goes well past the idea of simple Chuck-a-Luck. So the way we do this is we take every payout times its probability. So you lose $1 57.87% of the time. Real quick, as an aside, these numbers might not agree exactly with what you had in class. That's because depending on the simulation we ran, we're going to get different values slightly. They're probably going to be close. I would imagine they definitely match up to the hundredths place. Probably the thousands and 10,000s are off by a smidge. So we're going to be a little bit off in our answers, but that's okay. Anyway, plus 0 times that cancels, so no need to put that in there. Plus 1 times 0694 plus this is the fun part, payout times 0046. And we want that to equal $0. These are all dollar amounts. I should have had the unit. This is the dollar, and $0. So now it's just a matter of solving this equation, okay? Solving this equation. So what I'm going to do is I'm going to combine these two values, which should be fairly simple if I just subtract them, because I'm going to get 3, 9, I can put this down. We're down to negative, okay, 3, 9, carry the 1, 0, 5, right? Negative 5093, I think I did that right. Yep, looks about right. Plus P times that equals 0. Move this over to that side. This positive now. Okay, so right now, that negative 50 cents is being lost because of the first 3 components. This is going to make up for it. I'm going to divide that by that. I sure as heck cannot do that without a calculator. So we're going to do that here in Google. 0.5093 divided by 0.0046. I get a value of about 111. Now, again, that is going to be slightly different depending on our numbers from class. But it will be large, way bigger than 10 bucks or 15 bucks. And the reason being is because this game, when it's originally rigged, they pay you 10 to 1 odds, right? They pay you 10 to 1 odds. You'd have to profit $11, which means the payout would have to be 112 to 1. I'm pretty sure that's what I asked you, right? What's the payout? I've lost the problem now. Oh, here we go. What would the payout? 112 to 1 to profit $111. So to profit 111, a payout of 112 to 1, they are paying 10 to 1. It's good for them to know this because they can go, you know what, Chuck-a-Luck's a little bit slow right now. Why don't we make the payout 20 to 1? And then everybody goes, oh my God, Chuck-a-Luck's paying 20 to 1 on the big rolls, and everybody wants to play the game. Well, even if it's 20 to 1, you're still losing money, right? You're not losing it quite as much on average over time, but you're still losing money. And you will continue to lose money playing this game until they make the profit margin be a 111, which means the payout's a 112 to 1. And guess what they're never going to get close to? 112 to 1. Why would they do that? Because at that point, they don't make money anymore. They also don't lose money, but they don't make money. But Vegas can't afford to not make money. Right? Not losing is not good enough. They just have to earn it. So there you go. That's how Vegas works. It's how insurance policies work. It's how lots of stuff works. Hope that was helpful. There's also an extra credit that says do E2, but change the antes to make an expectation fair. I'm not going to make a video for that one. By all means, come by. I love to walk you through it, but it's a little trickier. Although I will tell you this. If you know what the payout was originally, that they were doing with the original distribution, it was about negative 48 cents or so. Let's make it negative 50 just to make life easy. Negative 50 cents. That's the payout on Chuck Luck, which basically means that you walk up to the table and give them $1, and they hand you 50 cents back, and they keep the 50 cents. Well, in order to make the game fair, if you gave them $1, they'd have to give you $1 back on every flip, on every game. Nothing. Money would change hands, but not really, because you both end up with the same that you had in the first place. So the question is, if you average a 50-cent loss every game, to erase that loss, all you've got to do is make sure they charge you 50 cents less, and that'll get eaten up in the calculation. So in other words, instead of charging 50 cents, or excuse me, instead of charging $1 for the game, if they charge you 50 cents with the same payouts, the average will be 0. Now I encourage you to run the math on that to make sure I'm not completely full of it. So in other words, instead of -1, make it -0.5. That makes sense so far? Instead of 0, make it positive 0.5. Instead of 1, make it 1.5. And that used to be 9, make it 9.5. That would be the payouts if you were charged 50 cents to play. Change those to those, run the average, and see what you get. Now, I'm saying that the payout is negative, or the original expectation was -0.5. If we found -0.47, you'd have to adjust it for that. Whatever we found it to be in class, which I don't remember now. So that's the extra credit, the E2. If you wanted to have a go at that one, you can always come by the office and I can run the numbers with you too. So hope that helped. See you in class.